Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to this ongoing online course on Engineering or Architectural Graphics Part 2, and we are discussing isometric projections here. So, this is the week 3 of this course, and by this time we have already discussed how to draw isometric projections of 2D objects, 3D regular solids, cut solids, combination of solids and intersection of solids. As I had said in earlier lectures also, in practice when we design especially the architectural and engineering components, we will never have the regular solids combining in very obvious ways. So, we will not have probably the perpendicular intersection, we will not have the solids intersecting or penetrating the other solid at the axis. It is all not going to be like what we have seen here. There are going to be various possibilities, and which is what we have to understand. How do we convert the 2D drawings, if we have the orthographic drawings, into 3Ds and vice versa. So, what I am going to do over the next 3 lectures is that I am going to take a lot of these practical examples of different objects, different building parts, building components, and from orthographic projections, which is the 2D drawing, we will convert it into the 3D drawing, and then we will do vice versa, that what if we are given an isometric drawing, how do we generate the 2D drawing for construction and replication from that. So, today we are going to try converting orthographic views to isometric drawing. So, I will take examples again. The theory remains the same, the basics remain the same, and we will just be taking examples and try to derive how it is going to be. So, let us look at this one. So, what we have here is this drawing. Now, I am not going to say that you jump at the conclusion what this looks like. We will only derive and draw following the process. So, the process is that we have the reference plane. Okay. So, one of this reference plane which we have taken is here, and the other one is at the back. So, one reference plane is here and the other one is here, and I am going to start drawing from that only. So, this was the, say this is the first reference plane which we saw, and then there is this distance between them. We can measure this distance. This is given as 32, and we draw another reference plane at the back. This is what we have drawn. Now, let us draw this. So, we know where these points are in both the planes, because these are straight lines. So, let us draw these. So, we arrive at these points similarly in the rear reference plane. This is what we have drawn. Now, what we see in the front is, so we are still drawing it light. We do not know where it is going to get cut. Okay. So, this you can see what all lines we have been able to draw out of elevation, this. So, we have been able to draw this hexagon exactly at the back. From the top we have seen these 4 lines, this, this one and sorry this one. Now, what we have missing is this circle here and this rectangle in the front. So, now what we have to do is we have to draw the reference plan for this one. So, from the previous plan, which was this entire reference plan which is coming here, now we have to cut out a square. So, if we look at this, probably somewhere here this square is going to come, okay, and on this we can actually draw this circle. Now, there is a certain height to it, so we can also take the height, which is where the top circle is going to come. So, we draw another one at the top, or rather we could have drawn the top one first, join the way we join cylinder, the edges of the cylinder, and that is it. So, we have the circle, which is what we are seeing here, we have these two edges, which is what we are seeing here, and the bottom of the circle and this. There is no other hidden line, there is no other line. So, all we are going to now do is darken the lines which we are seeing in the orthographic. So, let us draw, and the ones which we are drawing here which get hidden while drawing isometric will have to go in dotted. So, this is what I am doing, I am just darkening what is visible in the front, and then we will go to the back. In the front we also have this, the part of the cylinder, this is another line, and the rest of the edges are just dotted. You may want to draw it or you may not want to draw it, okay. I am just drawing it for the clarity. Now, you can see we did not know what this is going to look like. All we have done is we have just taken the correct reference frames and we have been transferring the object from this orthographic onto this isometric, the reference planes being connected with each other. We can't just be drawing reference planes without connection to each other. So, then the object will move, but if we are drawing it correctly, transferring the reference planes into the isometric, we are definitely going to get a correct drawing like this. Let us see more examples and you will understand how we are going to arrive at this. Now, this is the front view, the top view and the side view which we are seeing from here, seen in this. Now, let us start doing it again. So, what we have in the plan, if you look at this, let us draw this plan on the top. So, say we have this plan in the top, I will draw it almost up to this. So, I am drawing it freehand just with the help of a grid, but when you draw with the dimensions. So, in the plan in the top you can see this is what we are seeing. So, 5 and then in the center and then another one here, and then we have the same one coming here, and we do not have a line here. This is what we have seen in the plan. Now, I have drawn this plan on the top actually, which is what we are seeing from the top. Okay. Now, in the front, this is the drawing that we have. So, this is what we have in the front. So, what I am going to do is I am going to draw it from, so we have to understand, or maybe I can draw the side view first. Here, if you look at it in the side, what you have is, take this one. Now, there is nothing here, there is no edge here. So, what we know is that this edge is coming here, it goes down, okay, and it comes to the front like this. There is a dotted one which is coming here, and there is another dotted one which is approximately coming, say here. Forget about the dotted ones right now, but what we have is this can connect, but if we look at this point definitely has to go down. So, this edge is actually going to come down. So, we can draw the reference and bring it down. This is how it connects here. Similar thing will happen here, because if you look at it in the side view, there is no edge here. So, what we will have is this, and this portion of the plan, because this cannot be here, goes down. So, what we have here is, I am just drawing the plan. So, we got this entire thing down, right. So, we have this portion of the plan done, this. So, this portion is all covered of the plan. Now, we have to have, so I am erasing this portion which we have already brought to the level down. Okay. So, now in the plan we have a line. So, I just draw a thin line here. Okay. So, this is what we get correct as far as solid lines in the side elevation was concerned. We get all the solid lines correct, we get these lines in the plan correct. Now, we have to bring this one down. So, let us now look at the elevation. In the elevation you can see again we have, so what we have is, we have a straight line which is this. We have these smaller lines which are these. Okay. So, these lines are coming fine. There is a straight line. So, we can see this edge and these edges put together. We also have this continuous edge here, which means that we also have to draw this edge, which is how this object can be. So, we have arrived at the correct portions here. Now, the only thing which is left is this portion here. So, what I understand is this is what it is. Now, we can also see that this dotted line is because there is nothing here, but there is an edge here and here which is being seen here. So, even this one is done, we do not need it here anymore. Now, in the front we can actually see that there is a V which is forming like this. So, we can arrive at this point, we know the distances, we arrive at this point which is a V. Okay. So, what we know that from the top we actually have a thickness. So, we can't possibly have a line here if it is going there. So, if I remove this and I join these edges and I make a parallel one like this. Now, check the lines again. So, what we have here is this shape in the elevation which is done, the line. So, this dotted line is actually of this edge which we are seeing. So, even this is checked. So, we can remove the dots here. From plan we have already seen that this portion is fine, it is representing all the lines. So, we do not have any extra line more than what is given here in this object, and this object exactly translates to this. So, this is final, this is done and you can then finalize. So, very simply all we have to do is start by taking any one drawing and then reproduce the rest of the drawings onto the isometric in these different planes. So, what we have to do here is we have to understand how these planes are going to be joined, connected. Okay. And then we remove any extra line we might have made for taking the reference. If you wish, you can draw dotted lines if they are missing, otherwise you can just draw the final drawing as this. So, this is how we converted this drawing into the actual object. Look at this again, one more example. So, we are just going to do examples by examples and you will make sense out of it afterwards. Now, this is what we are seeing in the elevation. So, I am going to draw an elevation. This is a box like thing. Okay. So, what we see here is half of it. Okay, maybe I will just Okay. So, this is the front, and what we see here is that we have two lines coming like this. This is what our front view is. Okay. Now, in the plan what we see here is so this is the plan which I am putting on top of this, and we see that there are again two boxes. Okay. This is what we are seeing, and this is the side elevation which is actually being seen from this side. Okay. We are seeing it from this side. So, that is what is being drawn here, and I am now drawing the elevation, side elevation. So, we get this, and this, sorry, okay, not this exactly, we will start. So, what we are getting in elevation is, side elevation is this, and this. I have slightly changed the dimension, but now you can see here what we will exactly get. So, what we are getting at is, if you look at all the points together, we will just project this thing down. This is what we were seeing from the plan. So, this surface is actually moved down and it has become this, right. So, this rectangle has shifted down to this, and this rectangle which was in the top is now going to come further down to this. This is where this rectangle. So, if you look at this rectangle is come down to 2 units, right. This is where this rectangle is. So, when we see anything from the top, we are actually seeing it at various depths. That is what it means, but from the top we will be seeing it where we have drawn it, right. So, now I am going to erase the top plans, okay, which we have now moved to the lower levels. So, I am just removing those so that we can make sense of it. So, what we did is we moved this plan to this level, and we moved, there was another one here which we moved down to this level. So, in plan it is fine. Now, if you look at it in the elevation, we saw that there was an elevation here, and then there was an elevation, sorry, there were two boxes. So, now the box which was on the top, which was here, has gone to the back. The box which was here has gone to the back here, right, and the box which was here in the elevation has gone back to this one. Now, you can join the points. I am just removing these ones. Now, in the plan we have the rest of the portion as intact. So, this is what we can see, that the plan, this part, another box and another box, and here in the front you can see that we have this line coming intact. So, in elevation we have this plus one box here and another one here. In the side view we have already drawn, and there is no change here. Now, if I remove the hidden parts of it, you can actually make a sense of what we are looking at. So, all I have done is I have removed the hidden part of it, and I am going to darken this one for you. And then we will just check if we really arrive at the same drawings which were given to us in the initial stage. All right. So, what we see in the elevation first, so we have a continuous surface. When we have a continuous surface, we have to see a continuous surface. This is what it is, and then we see one box here and another one here, which is actually this. And if you were to draw dotted, so one box here and then another one, I am sorry, another one here. So, this is what we were seeing in the elevation and it is absolutely correct. For the plan we saw this, a continuous surface, which is what we are seeing here. Then we have one box here, which is the box here, which is this, and then another one here, which is this. I have skewed the dimensions little bit, but if you actually see, you will get this if you are drawing absolute dimensions which are given. So, which means that this isometric drawing which we have drawn out of this orthographic drawing is absolutely correct. Look at this one again. There are many examples, you can actually try solving them, and there are a lot of problems which are available on the internet and in all the books that you can go through on isometric projection. Try solving these exercises, it will make your fundamentals very clear and you can quickly convert the drawings. So, it is to increase your speed and also to improve your clarity when you convert the ortho to iso and vice versa. So, what we have here is, now we have a plan. If you look at this, we have a plan where there is one continuous surface here and then there is another one in the bottom, which is only up till this. In the elevation, what we are seeing here is that we have a continuous surface here and then this one at the back, and in the side elevation which is being viewed from this side, it is this. So, we will start by drawing all the three drawings, any one rather, but I am starting with the elevation here. So, what we have here is this. We do not know what level, okay, but all we are doing is we are just putting all the drawings together in one. Now, if you look at this, draw the plan. So, what we have here is, we have say approximately this much here and we have this here, there is nothing here. Okay. Now, when we are converting ortho to iso, we know that there cannot be any hanging edge, it has to converge, it has to merge. So, we automatically know that this face has to go back, but we will do it later. We will first draw the side elevation. For the side elevation, what we have is, we have this. So, there is a rectangle like this, there is another edge like this, and we also see this. This is what we are seeing. Now, if you start connecting these, so what we see in the plan is this continuous thing, one surface which looks fine. In the elevation, we have this continuous surface which looks fine and all the lines match, there are edges which are converging. Now, in the side, in the front elevation and the top, there is no line in the top view which is coming here, which means that there is nothing here, but then we also get to see that there is an inclined line. So, which implies that there is something, but in the top, if we were to have an inclined line here, we will be able to see it in the top. So, what it implies is that this edge is probably here, this is where it might be. So, we will see it from the side, which is what we are seeing here, but we will not see it in the top. So, if I remove this, this is what we are going to get. Okay. And then in the plan, if you look at this, there is nothing which is extending here. If you can see, there is nothing, there is no edge. These are the dimension lines which we are looking at, there is nothing here. So, this line is not there. So, if I remove this, you can actually see that what we see in the plan is this and then this. So, this incline when seen from the top will actually look like this. Now, in the front we have this edge, okay, which, and then we also have, say, this, which is what when seen from the side we will see this and this, which makes it a continuous edge. This is one edge and another one which we when seen from the side will look like this, and this incline which is actually seen like this, and there is nothing. So, we do not have, we will not see it from that side. So, what we actually have is this is a solid. So, all I am doing is I am just retaining the ones which are final edges, not drawing the dotted ones. So, this is a slant, this is a straight edge which we will get like this, and this is our final drawing. And then we will match the orthographic projections which were given to us in the initial phase. So, this is what it is. Look at it in the plan. We have one continuous surface which is coming here. We have another one surface. So, what this surface is actually an inclined surface. When seen from the top, it is appearing as one surface like this. This is what it is. Now, in the front elevation, we have one continuous surface as this, which is this surface, fine. And in the front, we have one surface which is seen here, and one surface which is this surface. So, and in the side we have this. So, if I am to draw the dotted one, just to tell you, this is the surface we are talking about. Then we have one surface which is shaped like this. Now, look at this. This is this surface that we are talking about. Look at this shape in ortho and what I am drawing in iso. This is exactly what it is, right? And then we have this portion which is actually, if you draw it like this, this is the triangular portion which we are seeing in the side. So, this is how this object will be, which is depicted by these orthographic drawings. Okay. There are several examples. You can work at all of these. I am just giving you certain examples. You can look at them, you can practice them at home. So, try practicing this one. This is going to be available in the presentations. I will take up certain other examples which are slightly different. Okay. The slant edges, you can try doing it again all the time whenever you are drawing it. Remember that no line should be left from the drawing. So, if there is a line, it must be seen. Now, if there is a continuous surface, you will not see a line. So, just as in this case, since there was a continuous surface, we cannot have a line here. No, it is not going to come. The lines will only come when there is an edge. So, if there is an incline, there was an incline here and there was a flat surface here, that is where we were seeing this edge. We would not be seeing this edge if this slant was to continue from here till here. No, we will not be seeing an edge in the middle in that case. So, that is what you have to be very particular about. No line should be missed and no extra line should come. The lines which are given in this orthographic drawing are exactly going to be drawn in the isometric projection. Okay. Now, look at this one. Let us try to solve this particular example. Now, what we are seeing in the top is, I am drawing the plan. So, you will have to draw it exact to the exact dimensions and using the reference plane, but I am just drawing it freehand. So, what we have here is that we have, say, a square and this is the circle that we are talking about, which is this circle. Okay. And then there are two lines here which are like this. This is the plan that we have been given. This is the axis which is this point, okay, through which the axis is going to pass. Now, if we look at it in the front elevation, first I am drawing the reference plane. Okay. So, what we have is, we have this as the reference plane. So, now let us just draw this. Now, in this reference plane what we have is this, there are two straight lines which are coming if I were to mark this, this is how they are going to come here. Okay. There is a straight line which is coming here, and then there is an inclined line which is going to come here. Okay. Now, if we look at this, these edges are coming, which means that this plane is different from this plane and this plane. So, this is one plane which we can very conveniently get if we look at this. Now, this is the incline which is probably coming and merging with this plane. So, if I bring it down and we take this incline here, it comes parallel, exactly parallel. So, this is the incline that we are talking about through these lines. We just push this face back, and this is what we are getting here. Okay. And this is the cylinder. We can draw the cylinder in the bottom at this reference plane. So, this is the straight cylinder that we get. This is the rectangular at the bottom. Now, I am removing the reference plane and I am only keeping the final drawing. So, the original reference lines have all gone, and what I have here is now match this one. So, what we have here is a circle seen in the top, a rectangle which is seen here, then a triangle which is seen in the elevation, and a rectangle here. Okay. And in the plan we have these two lines and the entire rectangle outside it plus a circle. This is exactly what we are going to get as our final object. So, all I have been doing is understanding where these lines will intersect and where the reference planes are going to intersect. Right? This is this object as it translates into an isometric projection. There is one more exercise for you to work at home, and in case it is a very simple exercise, all you have to do in this one is you have to draw these two circles at different levels. There are two levels where we are going to work, and there is a dotted line, which means that this is probably hollow. This, of course, we can see clearly that it is coming like this. So, this dotted line is again because of this hollow, the solid edge here, the dotted line here because of this hollow. This is coming for dimension. Circle we can make at both levels, and this is an hollow. So, probably when we draw, we will also be seeing the base of it because it is a thin sheet out of which the hollow has been cut. So, with this I will stop here. We will take up more examples of converting from ortho to iso in tomorrow's class. Till then, please practice the exercises that I have given in the class today and try solving them at your end. In case you find difficulty, any problem, you can write to us and we will try to solve your queries, and we will practice with more examples tomorrow in the class, so that you are absolutely clear about how to draw, how to convert from ortho to iso. After which we will take conversion from iso to ortho, how to draw orthographic drawings from isometric drawings. So, thank you very much for being with me here today. Have a great day. Bye-bye.